Have you ever wondered what really happens when you switch on your TV and your favorite channel appears instantly? No wires from the sky, no visible connection to space, yet somehow pictures in sound travels thousands of kilometers from space straight into your living room. It almost feels like magic, but the truth is that there is no magic here. It's science, beautiful, powerful engineering working silently behind scenes. Today, let's break it down in the simplest way possible. First of all, let's talk about how the signal begins from the earth. Everything starts at a broadcast station. Imagine a TV station like a powerful communication hub. Inside, cameras capture videos, microphones capture sounds. These raw videos and audio signals are processed and prepared for transmission. But here's the first important thing. Raw videos and audio signals are too large to send directly to space. So engineers have to compress them. Compression reduces the size of the data without destroying quality. This is done using digital encoding standard like MPEG. Now the signal becomes digital data, a stream of ones and zeros. Once compressed and encoded, the signal is sent to a powerful ground antenna called an uplink station. This station shoots the signal into space using high-frequency radio waves. Let's talk about how the satellite traps the signal. Do you really know how it does? Here is the time to actually listen to this. Now here's where space enters the story. High above the Earth, about 36,000 kilometers up, sits a communication satellite. This type of satellite is called a geostationary satellite. It stays fixed over one position on Earth, rotating at the same speed the Earth rotates. That's why your satellite dish doesn't have to move. When the signal reaches the satellite, something important happens. That's what you want to hear. The satellite does not store the signal. It does not process the video like a computer. Instead, it uses a device inside it called a transponder. Think of a transponder like a smart mirror. It, number one, receives the weak uplink signal. 2, amplifies, which means it boosts the signal. 3, changes its frequency. And 4, sends it back down to the earth. Why change the frequency? Now let's talk about this. Because if the same frequency were used for both sending and receiving, the signals would interfere with each other. So the satellite receives the uplink frequency and sends it back as a downlink frequency. And just like that, the signal travels back towards the earth. Now, number 3, let's talk about how the satellite dish receives the signal. Look at the satellite dish on your roof. That curved metal plate isn't just for decoration. Its shape is very important. It is a parabolic reflector. That curved shape collects weak radio waves from space and focuses them into a small device at the center called the LNB, which actually means low noise block converter. The LNB does 3 important things. Number 1, it captures the weak signal. Number 2, it amplifies it. And number 3, it converts it to a lower frequency that can travel through a cable into your house. Without the LNB, the signal will be too weak and too high in frequency to use. The signal then travels through a coaxial into your homes and into your house. Ta-da! So you have to turn on your TV and you're like, oh, I want to watch cartoon, I want to watch Spider-Man. So now, knowing this, let's now discuss how the decoder translates the signal. Like I said earlier, the signals are in ones and zeros. So how does the decoder does this job? So this is where the real magic happens. Your decoder is basically a small computer. Remember earlier when we said the signal was compressed and converted into digital ones and zeros? The decoder's job is to demodulate the signal. 2, de-encrypt it. Then number 3 means decompress the video in audio. While number 4, which is the last, says convert digital data into pictures and sound. Now, after listening all these things, let's try to explain them. Demodulation says the signal arrives from the satellite, is carried on the radio frequency waves. The decoder removes the radio carrier and extracts the digital signal. That's for demodulation. While in decryption, it says if you subscribe to a paid TV service, the signal is scrambled, your smart card or internal chip unlocks it. Now, let's talk about decompression. Decompressed data is expanded back into full video frames in audio signal. Let's talk about conversion. The decoder converts digital signals into HDMI or AV output, so your TV can display images and play sound. And within milliseconds, you see clear visuals, you hear sharp audio, all from nowhere but space. Then, there's another final question you need to ask. Why is the picture so clear? When you use a normal antenna, there are some ripples. You need to use antenna, you need to tune the antenna to a rhythm to get a clear picture. But when it comes to satellite, someone will ask, why is satellite TV usually so clear? Number 1, it is because it uses digital transmission. 2, signals travel mostly through space which means there's a less interference. Number 3, error correction code fix small transmission mistakes. Number 4, high frequency band like cool band allows high data rate. However, heavy rain can sometimes block signal. This is called rain fade. Water droplets absorb high frequency radio waves, weakening the signal. That's why your TV sometimes shows no signal during storm. Next time you pick up your remote in change channel, remember you are communicating with a satellite floating 36,000 kilometers above the earth. Invisible waves are traveling at the speed of light. Complex electronics are working silently, and all of it happens so you can relax and watch your favorite show. That's the power of satellite communication. It's not magic, but human innovation at its finest. So please, if you have enjoyed this video, I want you to subscribe to my YouTube channel. My name is Benedict Godswill, and you're watching Benedict Godswill TV on my channel. So stay tuned for my next video. Bye.